A coin is considered fair if it has an equal chance of landing heads or tails. And it would be impossible to land any other way. When we have two options, both equally likely, we think of a coin as having a 50-50 chance of landing tails. The 50 refers to 50% head and 50% tail. Assuming the coin you're using was fair, the theoretical probability of flipping tail is 50%, a half or 50%. Take a moment to look at your result for 5, 10, and 25 and 50 flips. Consider how the relative frequencies compare to the theoretical probability. You'll most likely notice that with a large number of flips, so if you increase the number of flips of the coin, the relative frequency gets closer and closer to 50%. So in your collaboration, when you're flipping a coin, you need to keep track of the number of times that you get the result and then do the division. Basically here, we flip the coin once, we got a tail, we flip the coin another time, we got another tail, we flip the coin another time, we got another tail, but we have head and head in the next set. So you have 3 tails divided by how many times you flip this? 5 times. So you get 3 divided by 5 or 60%. If you repeat this process, for example, if you flip the coin one more time, you get a head, but next time you get a tail. So this is just a sample. Your answers are going to be different. So you flip the coin one more time, you get a head. You flip the coin one more time, you get a tail. You flip the coin one more time, you get a tail. So how many tails are in 10 flips? You have 1, 2, 3, 4, 5, 6, and 7. So that's how you end up with 7 divided by how many flips? Now in total, you had 10 flips. So that's how on the denominator you get 10, which is 70%. But if you repeat this process more and more, your number is getting closer and closer to 50%. So in your breakout room, when you're discussing this question, you need to keep track of the number of times you are flipping the coin and how many times you get a tail. Okay, let's get back to the lecture. Note that at 50 trials, the relative frequency of 48% was quite close to the theoretical probability of 50%. Make sure you hold on to those results and have them available when your group does a collaboration for 2.1. Introduction to probabilities. What are the learning goals? By the end of this collaboration, you should understand that the probability of an outcome can be estimated based on its relative frequency. So probability in its essence, when you're talking about probability for simple events, we can basically use relative frequency that we learned in previous chapter. As the number of trials increases, the observed relative frequency of an outcome approaches the probability of that outcome. By the end of this collaboration, you should be able to use a relative frequency to estimate a probability and compute proportions. Remember that when we're talking about proportions, it means that you have fractions. You have a numerator and you have a denominator. Numerator and denominator. Take a look at this case, this scenario. US Census data, American Community Survey. The United States Census Bureau collects large amounts of data about the population of the United States. The table below contains 2021 American Community Survey ACS data showing marital status of people of the age of 15 or over living in the United States. Note that 2 US states, Hawaii and Kansas, have a minimum marriage age of 15. Okay, I didn't know that. Numbers in this table are in millions of people. So when you see 992.7, it means that you have 92,700,000. Each number is rounded to nearest 0.1 million, which is 100,000. Remember that here you have 1, or you can basically write it as 10 divided by 100, and we can simplify this, multiplied by a million, and then you can cancel out some of these zeros, right? So you end up with 100,000, and that's how we got this number. Okay, so here we have the marital status, never married. You have 92,700,000 people. Now married, not separated, 130.4, separated, 4.6, widowed, 14.8, divorced, 28.8. And this number is the total. It means that if I add all of these numbers together, it becomes 271.3. Use the table to answer the following questions. Okay, let's begin. What proportion of the adult population in the United States is married? All right, you want to answer some questions. Provide your answer. All right, so married, how many people are married? We're going to locate those. Okay, I see now married is 130.4. So I'm going to use that piece of information. 130.4. Out of how many? Out of the total number of people in your collection is 271.3. So 130.4 out of 271.3. If you do the division, you're going to get approximately 48.1%. So about 50% of the population are married. So since the question says, if necessary, round it to 3, you can write it this way as well. So you have 0.481. So when it says round to 3 places, decimal places, it means that you have point, which is your decimal point, and 3 digits after that. Or you can convert it into basically a percent to feel more comfortable when you're talking about this. For example, 48%, roughly 50% of, less than 50% of the population are married now. Okay, let's go to the next question. What proportion, again, when we're saying proportion, we need to form a fraction. What proportion of the US adult population never married? Never married. Okay, let's take a look at this. We have never married, which is the very first data here, 92.7. 92.7 out of the whole population, which is 271.3. So let us do the calculation. 92.7 out of the total, which is 271.3. So let us do the calculation. This number is about 34.2%, or in 3 decimal places, you get 0.342. So that's how you calculate the proportion. Now the question is, the data indicates that 48.1% of adults in the US are married if we choose one adult at random, what is the probability that this adult is married? So what is the probability? Probability is denoted by P, that random person is married. Okay. Remember that when we talked about probability, we form a fraction. How many people are married in the United States? This is basically question 1. How many people are married? 130.4. So 130.4 divided by out of how many people? 271.3, which is again must be the same as what we calculated up here, 48.1%. 48.1%. That is the probability. Must be exactly the same as question 1. The probability that a randomly selected adult in the United States is married is the same as the relative frequency or proportion of the population of adults in the United States who are married. A common practice is to use P to represent probability. So the probability that a randomly selected adult in the US is married can be written as P of married, or you can write it this way: the probability of that person is married. Question 4, use the relative frequencies to answer the following question. If we choose one adult, guys, please note that I'm using one adult. Later on, we're going to talk about central limit theorem and choose more than 1%. If we choose one adult in the US at random, find the probability that person is widowed. Okay, find the probability that that person is widowed. We need to take a look at our table and form a fraction. So on top, we're looking for the number of people who are widowed, 14.8, right? So you have 14.8. Let's write down 14.8 on top. Out of how many people? 271.3. So if you do the division, you get approximately 5% or 0.05. That is the probability that you randomly select a person, or you see someone on the street and you're wondering, okay, what is the chance that person is widowed? It's just 5%. Let's make it more interesting. A college girl club has 123 members. 83 of them live on campus. 22 live in the campus adjacent apartment complex, and the remainder commute from their home. Suppose one of these students is selected at random. Are you more likely to select a student that lives on campus or a student that lives in the apartment? So take a look. Here you have in total 123 people, and 83 live on campus. You have 22 live in apartment complex, and the rest of them commute from home. So you have 123 minus 105. If I add these two numbers together, I get 105. You get 18 that commute. So since the frequency for people who live on campus is 83, we expect to see a higher chance. So this is how we can write it. Since the frequency or the count for those of you who are looking for different wording. Count of students live on campus is higher. We expect to select a student that lives on campus. Okay, let's move on to next question. What is the proportion of these students that live on campus? Okay, when you're talking about the proportion, remember that we are basically talking about the probability. Proportion, relative frequency, and the probability. So all of these are the same. The probability or the proportion to live on campus is, you have to do a division, right? Here on the numerator, how many people live on campus? It is 83 of them. 83. Let me use the same color on campus. 83 divided by how many? In total, we have 123 people. If we do the division, what do we get? We get a number that is close to 67%. So this is 67% or 0.67. Again, this is the exact same as relative frequency. Relative frequency is also 67% or 0.67. If you randomly select a student from the Geek Club, what is a reasonable value for the probability of being a commuter, right? Here we had 18 people to be commuters, so I'm going to use the green color. Commuter people, you have a fraction as usual. On the numerator, you're going to write down 18. 18 commuters divided by 123, which is approximately 14.6% or 0.146. So long as we know the relative frequency of each group in a population, we can determine the probability of selecting a member from that group. When we select at random from the population, but what if we don't have the relative frequencies? Take a look at this experiment. Tossing a coin. In 2.1 preparation, you conducted a probability experiment using relative frequencies as estimates for the probability of flipping tails. A probability experiment, this is a good definition, is an experiment that is run over and over with the outcomes recorded. For these questions, you're going to have different answers based on your experiment on the probabilities. Remember that. So answers for question 8 and 9 are going to be different. As you're discussing these questions with your group mates, you're going to have different answers.